All right, looks like we're live.
Super.
Take it away,
Yay.
Andrew.
Yay. Yay. Great to be back after a little hiatus. I think I missed the last one, so I think it's been about a month. But welcome back to this one time. My name is Andrew Gillies. I'm the CTO and one of the co-founders here at Urban Machine. And of course, Jorie Wisnefski, who's the marketing manager here at Urban Machine, who's always leading the charge. And today, joining us again, Alex Thiele, my co-founder. We're heading the software efforts here at Urban Machine.
Good to be here.
Yeah, absolutely. So a quick recap. I always like to start with like why we're doing this. Really, the purpose of this podcast is to share a little bit about our journey behind the scenes. At Urban Machine, we're building a giant robot system. We'll get into all that again, like we usually do. But we always hear that term "hardware is hard," and it really is. But you don't always hear like why, like what are the details, what makes it so hard. So really, what we're trying to do on this podcast is pull the curtain back a little bit and give people sort of that inside view. And really, the hope is to, by sharing these stories, by putting this information out there, hopefully other folks maybe can hear something in there, and that might help them reach their goals a little bit closer, a little bit faster. There's a lot of folks working on really great hardware projects, and really what we want to do here is just help everyone move down the field a little bit faster because we got a lot of grand challenges out there, and at some point you need hardware to address those grand challenges. So we really want everyone to move a bit quicker. Yeah. And so today, the details that we're going to be diving into, pulling back the curtain on, is the actual interface between hardware and software. At least what we at Urban Machine, what we sort of define as that key interface. And so the title of today's episode was "Catastrophic Connections," and
Yeah, I like it.
specifically, we're going to be talking about a file format and an interchange format called the URDF. Now, if folks have worked with ROS platforms before, you might be familiar with this, but we're going to get into it. We're going to get into how we use URDFs at Urban Machine, like why we think it's a great tool, and where we've had to kind of build infrastructure around that as a tool, and also what we've heard from the community in terms of like where it might need to go next. Yeah.
Which I think
Um,
is really it's such a good topic because of the show's theme itself is just working together. And this is a topic where you two, even though you're on the same engineering team, you're working on very different things. Yes, they work together, but this is a way for you guys to communicate, just like this is a way for us to communicate with a larger audience, right?
yeah,
Yeah,
and
I
absolutely.
like
the whole communication effort is, I think, the most important thing because robotics is so multidisciplinary. You
it.
know,
Okay.
you are combining software and you're combining mechanical engineering and electrical engineering and all this like physics and how things move and the masses. So, like, I don't know very much about anything except for the software bit. So, having really structured communication between different disciplines is super important.
Yeah, absolutely. It's a systems problem, right? Like robotics is absolutely a systems problem, and one of the things that makes system problems a little bit easier is having really crisply defined interfaces.
Yeah.
Interfaces, and the URDF happens to be a very helpful interface between the hardware and software team.
Okay.
Do you want to like get into that a little bit, or
Yeah.
like what that means, or like what that is?
Yeah, I can talk about like if I was going to program a robot, but I didn't have a real robot, what would I need? Because you can imagine just building a robot in a game engine and like just moving things around or doing things in like a physics simulation. But the very lowest level you need is you need to know where, like what things can move, like how they can move, what constraints they have on their movement, and what are they moving, right? So really what I'm describing is joints. You need to know what the joints are in the system. You need to know like their orientation and basically the 3D position of a bunch of things. So if you're a game developer, this would be your like asset, your 3D models, and the bones, all the joints inside of that system. And it's kind of similar. We do need that we do need all those like relationships between positions and the measurements of everything, so we can start telling those joints to move and do different things on the software side, and just kind of see how the robot acts and how we need it to do, what it needs to do to solve these problems.
Yeah, and joints. Joint. I think when probably people hear joint, they might think of like their elbow joint or the knee joint, right? So you have like a single pivot, and it's moving like this, right? In robot land, we might call that a degree of freedom, right? So it's really about capturing degrees of freedom in the system, and within a URDF, a joint can actually represent any defined motion between two different rigid bodies, and that could be like a wheel spinning. It could be something like a pin joint, like your elbow. It could be a slider joint, like imagine a piston sliding back and forth in a linear action, right? So there's a collection of these different joints that each has their own kind of characteristics. And yeah, at URDF, what that lets you do is like pin down and define what those characteristics are, parameterizing those characteristics, and how that sort of brings your whole robot together. Because you might, in a single robot, have how many. So in our nail picking cell, how many degrees of freedom we have? It's like
Oh my god.
26, something like that.
Maybe more.
Yeah.
The fact that I don't know is probably means it's a lot.
Right. It's immeasurable. Okay, that's
Yeah.
fair. And then had you guys used URDF before, like working together?
Not together. This is the first time that we've worked together. I've used URDFs on other projects before, and I think you had.
It was a first for me.
Yeah.
Yeah,
Okay.
this was a first. Yeah.
Okay.
Yeah. So I've used
find it?
URDFs on other
Oh,
projects.
because you had already used it. Yeah. Yeah.
Yeah. So I'd already used it.
Andrew taught me everything I know.
So yeah, the URDF file format has been around for a while too. So this came out of like early days of ROS and Willow Gross, or like the OG ROS movement in the Bay Area, which was probably like 2008, 2010, I think, somewhere in that era, when they were coming up with like the original TurtleBot or the PR2, and they really pioneered this file format as like, we really need a bridge here to describe this mechanical system. So they came up with the structure, and within the community, it's really stuck. Like here we are, like 12, 15 years later,
Yeah.
using that format. So
In
it's
production.
Yeah, in production. Yeah.
Okay.
Yeah, and I would go so far as to say, like, one of the benefits it has is it does convey a lot of information, but it also strips away a lot of information. Because what Andrew and the hardware team is working on is they're working in the space of individual parts from individual vendors that are assembled in a certain way with these screws and these motors, none of which is important to program the robot. What I care about is what shape does that look like? What is the physical shape of the robot, and what positions does everything end up being in? And the URDF is a nice middle ground because it exports everything. We end up getting everything as meshes. We have all the 3D meshes of the robot, and we also have like a structured description of the locations of all of those meshes. So we can use it for collision prevention and collision detection and path planning, and we can move those meshes around using the joints, but we don't have to worry about the individual washers in the system, which is kind of the CAD level.
And so this is a way for you guys to communicate, here's what I did, and here's how it will affect what you did, and vice versa.
Yeah, absolutely. So it's almost some like, I think like thinking about it as a compression of the CAD is really interesting, where we're just pulling out just the very specific parameters that you need, which is really how is this going to move in 3D space, and what sort of 3D envelope does it occupy?
Yeah.
And on our side, we've actually gone to great lengths to structure our assemblies and structure our CAD in a way that is friendly for the URDF conversion process. So like we put a lot of structure around our CAD systems to make that translation easier, to bridge that gap. And it is great because we get to think about, okay, what are the software needs of this? How are we going to support that? And what are the key parameters that we need to think about up front earlier in the design process? Because I've seen this on other projects before, where the URDF becomes almost like this afterthought that people cram CAD into just to get it to work at the last minute.
Okay.
And you can end up with some organizations where it's it's a tricky process if you don't think about it up front. And usually what you end up with is like maybe there's one person at an organization that really understands URDFs, and everything ends up funneling through this individual. It's a lot on one person's shoulder. It's sort of this like mercurially mysterious process. For us, we put in a lot of work and matured some of that export process so that each engineer can get it out there, and there's not as much of a barrier of iteration and like lag between the hardware and software teams. We keep that loop very, very tight by structuring on both sides with the expectation that that's always going to work.
Yeah.
So is this
that was
something
kind
that you guys had to meet on and like keep fine tuning
Yeah, absolutely. Yeah, and
to continue the process?
yeah, and we've had to. There's a handful of aspects of it. One is like how do you get your CAD into this URDF format? We use Onshape here as our CAD platform at Urban Machine, and luckily there's an open source conversion tool written in Python. It's actually a professor in France, Gregoire. Gregoire, if you're out there, thank
Shout
you.
out to him.
And we've taken his tool, we've made some modifications to it internally to put some features in there that we wanted. But he really got the ball rolling on getting Onshape land into your DF land. So we use that, but we've had to put a lot of work into that. That only gets you the export process. It doesn't get you the structure within CAD to actually do this conversion.
Okay.
So we've done some additional work, and yeah, we have a very, very long spec and document now that we've developed at Urban Machine of how to do this in this rigorous manner, which is pretty mature at this point.
Yeah.
Yeah.
So.
I think the other thing, maybe you can elaborate on this a bit, Alex, but the other aspect, we're definitely pushing the boundaries of URDFs. They're really created with a single robot in mind, whether that's like a mobile base like the TurtleBot or the PR2. Effectively, they only had in mind like one single robot, and that mapped to one single URDF. Yeah. At Urban Machine, we've taken this modular approach to our system. Our whole robot is actually a collection of all these different smaller robots all working together, which kind of necessitates having multiple URDFs that we all have to handle. So this idea of like modularity and chaining URDFs together is something that we've worked really hard on as well.
Yeah. I think we've got maybe like 15 unique URDFs in there. It's almost turned into kind of a fleet robotics architecture, because we have multiple, picking robots that can grab nails and from different sides, and you never know, we're going to get another picker cell, and then there's 4 more robots and another frame, and then another picker cell. Now you're dealing with 12 robots, 3 cells, all arranged in different locations. So we can just copy paste different URDFs, add them to the system in this like distributed architecture.
Do you think, Alex, having not worked with it before, do you think that almost was a benefit to you because you had no like preconceived notion of like this is the way it has to be, so you're able to like see a band-aid, see a way to patchwork it and make it work for your unique situation?
Yeah, it's a good question. I think what I've learned working in the robotics space is that there's no right way to do things, but there's a lot of ways to do things in a wrong way that'll bite you later. And it's all about like when will the pain hit, and like for us, we just iterate on the system, and as we add more features, we delay the inevitable need to expand scope even further. So right now we could probably scale to like maybe 30 or 40 robots. But anything past that, then we're running into compute issues. So I would never say like this is the best way to do it, but it certainly has worked for our needs.
Okay. And Andrew, do you see like a better way to do it down the line as we add stuff, or is this where the system is?
Yeah, so it's interesting. So the URDF format itself, like I said, is a little bit old. The community is actually speaking a lot right now about what might come next, and what are some of the shortcomings that we're really hitting a wall with now that there's a lot of folks developing robots that aren't just a single mobile base. And the big question is, do we revamp URDF and retrofit that, or is there some other protocol that we can jump on? So folks are looking at, for example, another protocol might be something that they use in the gaming world. The gaming has done a lot of work around this. So I think it actually came from Pixar, but NVIDIA is adopting it. It's called the USD, the Universal Scene Description, as a
Okay.
way to capture this information. So there's active work around bridging URDFs into a USD format. But this is an active discussion right now. Like a Silicon Valley Robotics Association has had a handful of working sessions which we participated in,
Oh, great.
looking at like what are some of the current barriers, not just across the community with URDFs, and looking like what could come next. So I'd say it's a very active discussion at this point. For us, some of those challenges that folks are facing are not directly applicable. The big one for us is this idea of like modularity and how you bring that together in a larger complex system. URDF has other shortcomings. It only works in a strictly like top-down tree format with sort of child-parent relationships. So if you have a robot that has the technical terms like a closed-loop kinematic chain, but if you have like looping structures like a 4-bar mechanism, it doesn't work for that. It's like not designed to handle that. And there's a lot of folks working on 4-bar linkage type mechanisms. So these are some of the other weak points. It can only handle rigid bodies. It doesn't handle, it doesn't capture sort of like multi-material bodies. So there's other points there that folks in the community are interested in improving that aren't directly applicable to us. So yeah, we'll see what happens. Definitely active conversations happening around that right now.
Yeah, it's
And
definitely.
and so this conversation that you guys have participated in, how have you gone about contributing? Like, is it a Zoom call? Is it you've been there in person? How are
Yeah,
you?
it's been a combination. I think the last couple have been in person.
I've only
Yeah.
been to one. That was
Yeah.
in there was a nice like working group meeting at the Autodesk Center in San Francisco, and
Okay.
like we talked file formats for about an hour or two.
That's
Yeah.
awesome. But that's how the conversation starts. That's how people get thinking. I mean, that's ultimately how our robot came to be, right? Just thinking about
Yeah.
something a little differently than the way things have always been done.
Yeah. And actually, before I realized, we actually have a video of
Oh, awesome.
our URDF system. So before I forget, I should bring
You
that up
should.
pretty
Yeah.
deep into the conversation here. Let's see if that's going to go for us. Oh, sad face. I see 3 dots. Let's try one more time.
Okay. It's the afternoon after all, so
Yeah.
the
There we
reception.
go.
Come on, you can do it. There we go.
Here we go.
So
What am I looking at?
this is the like all of the URDFs combined in our system as
Oh,
the robot runs, and so yeah, all of those 3D models you're seeing, those are all specified in various URDF files, and you can see the robot grabbing at virtual nails and looking at virtual wood, and all of those joints being commanded to move different positions. So this is tremendously useful for me as a software engineer because I do most of my development on my laptop without being connected to a real robot. I'm
sure.
just moving these 3D models around and observing and making sure that it looks like what I would expect to happen in the real world before I go and
Ah,
test on the real robot.
sure. Oh, that's so cool.
And you can see the red, you sort of see this red envelope flickering. That's the collision envelope for each of the gantries. So you know, like that's the keep out zone, again defined by the geometry of the system with a safety boundary.
Okay, so if I see the red, that means that that that's not a good place
Like
for
a
placement.
space reservation.
Yeah, so see the way you can think of it is any area that's covered in red, no other robot can enter that.
I see.
Yeah, and so that's our collision prevention system at work there.
Got it. And so
Yeah.
that tells you, it communicates a message to both of you. You and
Yeah.
Andrew.
To me,
Yeah.
it's nice because I can see it working, and I feel comfortable that the space that is being reserved is the space that the robot is actually moving through, and all the other robots know where they are, and that it all looks correct. So I expect not to see any collisions.
Yeah. That's
Yeah.
fantastic.
Yeah, you can also see, so each group of colored items, it represents like a single rigid link in the system. So like you see the yellow here, that's like one axis of our gantry. So like each color represents a different solid body moving through space.
I'm
Okay.
going to just say this. I actually didn't know that.
Oh, okay, yeah.
I just learned that. That makes a lot. I always thought you guys set the colors.
No, it just assigns that. Yeah.
Oh
yeah,
man,
to
that's
solid body,
really
yeah.
useful.
Okay, there you go.
All right.
We're learning.
See, this one time you learned something.
Yeah.
It's a show for learning something. I love it. Thank you
We
for
also
sharing
have
that. And so oh, go ahead, Alex.
forklift. As a joke, I asked Andrew to give us a forklift in the URDF, so we can actually drive that around using our joysticks.
We have to have a little bit of one-upsmanship around the,
Yeah,
or the
yeah.
Yeah.
the URDF is an interface, so it's a little chance to show off. So like we lob challenges back and forth, like, oh yeah, you want a forklift? Here's
Oh,
a
we'll make it
forklift.
drivable.
Okay, well I gotta
I'll
tell you
show
about
you a
that
forklift.
forklift.
That's amazing. So, that's how we grow. You have to challenge each other a little bit, right? That's
I want
awesome.
extra on my forklift.
That's right. Yeah. Get
So
it
if
back.
people want to contribute to this conversation, you said that one is taking place that you guys are participating in at the Silicon Valley
Silicon Valley Robotics, yeah. So that's
Robotics.
Andre Cray leads Silicon Valley Robotics, and there's meetings every quarter. So you can go to I think it's svr.org and sign up there and get notified about events. There's also events at Circuit Launch discussing these topics. So and SVR is headquartered at Circuit Launch here in
Okay.
Oakland. So those are two good organizations to reach out to start participating in some of these conversations. Yeah.
Awesome. And someone mentioned Autodesk.
Yeah, Autodesk has been a fantastic host to these events. It's a beautiful
Okay.
space. They have the on Pier 9, they have the Innovation Center there.
Great view.
Yeah, great view of the city.
Good snacks.
Yep.
Yeah, I'm bummed when we're Andrew, you're bringing the demo robot to Autodesk in a couple of weeks.
I sure am.
Um,
Yep.
yeah, so I'm bummed to miss the view and to miss demo robot going in. That is June 9th, Friday, June 9th.
Yeah,
Yeah.
and we'll be there, I think, Thursday afternoon. I think we're setting up on Thursday afternoon, so I think
Yeah,
we'll
but
be
that's
there
just for the Autodesk folks.
I
That's
see.
for the
Okay.
employees of Autodesk, yeah.
Okay.
All right. Well, this is
Yeah.
another good episode. I learned something again. I love that about this show.
Yeah, absolutely. Yeah. So, yeah, if I think we called out the other organizations. Also, always feel free to reach out to us if you're interested in either robotics or working on our mission here at Urban Machine, which is reclaiming lumber from construction and demolition sites. I think I didn't say that at the top. But we're also developing a large, cool robotic system to help work on sustainability. So if you're interested in that, reach out. Urbanmachine.build is our website. We're always
That's
looking
right.
to speak with passionate, talented folks.
And we're
Yeah.
hiring a mechanical engineer.
We are.
Oh,
Yes, we are. Yeah, absolutely.
So they can apply right from our page, right?
That's
From
right.
our website.
Yep, they sure can. Yeah,
Very
yeah,
cool.
absolutely. Awesome.
All right. Thank you guys. I appreciate it.
Thank you. Yeah, thanks, Jorie.
Have a good
All right,
one.
take care. Bye-bye.